the rocky hills of southern India. The stage is set for a performance of one of the most spectacular dances in the natural world. Peacocks are gathering. This, surely, is one of the most glamorous of all sights in nature. 150 shimmering eye spots carried on tail feathers that are 6 feet long. So how did such glories evolve? It seems it's all down to the female. The brighter a male's colours and the greater the number of his feathery eye spots, the more attractive she will find him. But colours and plumes like these come at a cost. The immense tail makes flying difficult. The males are literally weighed down by their feathers. Yet the colours they carry are clearly very important to them. So why and how has colour taken on such value? To understand that, we have to think back to when it all began. 700 million years ago, our planet was far less colourful. But the first animals, it seems, had eyes that were unable to distinguish colours anyway. Gradually, however, this changed. I am in Costa Rica, a good place to see how valuable colour can be. This toucan likes fruit, and its ability to choose ripe fruit from unripe depends on colour, because the ripe ones are black. And this capacity of choosing between different colours was a very important stage in the evolution of colour vision. Birds, close relatives of dinosaurs, appeared before mammals. The first mammals, as far as we can tell, were mostly nocturnal. Colours are not easily distinguishable at night, so why evolve the ability to detect them? So it seems that the first mammals themselves were not very colourful. And this is still largely true today. Most are shades of black and white, or brown. But there are exceptions, and one of the most dramatic lives in the forests of Gabon in West Africa. These monkeys are mandrills, a kind of baboon. They live in large troops. Most are females and youngsters, both of which are brown. But the males are different. They, when they're young, have very plain faces with naked muzzles. As they grow, their faces begin to change. Testosterone begins to flow through their veins. When they're about 6 years old, they leave the troop and start to fend for themselves. As they become sexually mature, colour appears in their faces. And what colour! Mandrill males are the biggest of all monkeys, weighing over 30 kilos, enormously, frighteningly powerful, and their colours say so. It is not only his face which is coloured, so is his rump. Both are fearless declarations of his health and strength. And this male is more than happy to prove just how strong he is, should any male dare to challenge him. Not surprisingly, mandrill eyes are particularly sensitive to colour. And it's the brightness of their colours which signals their status. There are 4 males in this troop, and they're constantly flexing their muscles and displaying their colours to establish who is the strongest. And not all disputes are settled peacefully. They emphasize their ferocity by gestures, such as grinding their teeth. If that doesn't work, the highest-ranking male will fight. And the others know it. It's better to let colour do the talking. Mandrills see the world much as we do and have 3 kinds of colour-sensitive cells. But another group of animals has colour vision that's far superior to that of any mammal. Birds. Their ability varies from group to group, but you can judge how good they are from the colours they use to signal to one another.
Hummingbirds have excellent colour vision because that enables them to spot brightly coloured flowers, which contains the nectar on which they feed. So this artificial feeder is a big success, brightly coloured down here and containing sugar solution, artificial nectar, up there. But hummingbirds also use their ability to see colour in a different way, to attract a mate.
Most species live in South America, where there are flowers of some sort all year round. A few, however, have spread northwards into the deserts of the American Southwest. In this vastness, it's hard to get noticed. especially if you are a small hummingbird looking for a mate. But this male Costa's hummingbird uses his colors to send a secret message. Out in the open, flashy colors can attract unwanted attention, so he keeps them hidden most of the time. A slight turn of the head, however, provides a tantalizing glimpse of what he has to offer. He spotted a female. She's feeding. Hummingbirds live fast lives and need plenty of fuel. So if he is to attract her attention, he needs something eye-catching. Time to reveal his colors. Erecting the iridescent feathers on his neck, he positions himself to catch the sunlight. Seen at just the right angle, his colors are dazzling. Aerobatics like these take a lot of energy, so his performance can give her clues about his health and fitness. Every second she takes to decide burns up his energy reserves. So he can only hover for so long. At last, his colors have persuaded her. Displaying your colors is easy out in the open. Birds which live in dark forests, however, have to work harder to get noticed. The rainforests of New Guinea. Here the trees stand 100 feet tall, with their crowns forming a near continuous canopy. But here and there, there's a small gap through which a shaft of light illuminates a patch on the forest floor. A stage for one of the most versatile dancers in the natural world. A bird of paradise. There are over 30 different species. This one, understandably, is called the magnificent bird of paradise. A male. Before starting his show, he clears his stage. The bare brown earth will make his colors stand out better. He takes particular care to remove anything green. That color will be the main feature of his display, and he doesn't want any competition. Satisfied at last. A sapling in the center will serve as his dancing pole. His costume must be immaculate. Plumes like these need careful attention. time to summon the audience. The first to appear are all young males. They won't develop their colours until they're 7 years old. They have come to watch and to learn. At last, a female. She looks much like a young male to our eyes, but he can clearly tell the difference. She will judge him by his performance and the brightness of his feathers. She does that from directly above him. He puffs up his feathers and swings round to show her his colours. For years, naturalists only watched his performance from ground level. But the female does so from above. And from there, his brilliant green colours stand out vividly against the brown of the ground. A pair of bare quivering quills sprouting from his tail add to the excitement. This is one of the most complex of all courtship dances, and we're still unaware of the details that she may regard as critical. The prize-giving, however, is unmistakable. The colour vision of birds is mostly excellent, but that of many insects is almost as good. Butterflies. They too have evolved an astonishing variety of colours and patterns. The wings are covered by tiny scales like tiles on a roof, and it's they that produce some of the colours. Some have pigments. Others reflect light to produce a shimmering iridescence, with colours that change according to the angle from which they're viewed. But some butterflies use colours that are invisible to our eyes. The glorious colours of an English meadow in bloom is a delight to the eyes of many of us. But their purpose is not to appeal to us. It's to attract insects such as butterflies and bees. Most of these plants depend on insects to pollinate them, and they use their bright colours in order to attract insects. But to understand what an insect sees, we have to be able to see it through their eyes and from their perspective. And happily, we've got a camera
that enables us to do just that. This camera setup lets us look at that flower in two different ways. This camera is an ultraviolet camera because it has a filter there that only lets through ultraviolet light. But at the same time, this filter also reflects normal light, and that comes into this camera, and that shows what we can see. So I can compare the two very easily. That's what we can see, and that's what the insect sees.
Flowers have evolved these ultraviolet markings for the benefit of insects such as butterflies. This particular one lives in the rainforests of eastern Australia. It's a blue moon butterfly, a male. You might not think that it's the most colourful you've ever seen, but with our ultraviolet camera, his wings take on a magical look. The brighter his patches, the more attractive he is to females. But ultraviolet markings like these can also be seen by the blue moon's main predators. Birds can see them just as clearly. So flying around with a bright signal like that on your wings could be dangerous. For a male, however, it's worth living dangerously. If he can mate with one or two females in his short lifetime, his colours will have been a success. But he has competition. He will have to defend his territory if he is to secure a mate. Butterfly wings are fragile, so physical combat is to be avoided. Disputes, instead, are settled with aerial displays. A female has been watching from the sidelines. Time to show her his colours. In her eyes, he's simply dazzling. Ultraviolet colours are part of the spectrum that insects can see and we cannot. Recent discoveries have revealed that some animals can also see a characteristic of light that we cannot detect.
Sunlight contains rays that vibrate in many different planes. In polarized light, they vibrate in only one.
Light may become polarized when reflected off a shiny surface such as water.
Unlike us, some animals can see polarized light, and they can exploit it in many ways.
One creature that does so lives on these vast mudflats in northern Australia. These eyes, on stalks, belong to a male fiddler crab. And they can see in a way that we cannot. As the tide goes out, the crabs emerge from their burrows. His giant claw is too large to be used in feeding. Instead, he uses it to attract the attention of females by waving it with vigor. The crabs can see objects that are close to them reasonably well. But their long-distance eyesight is not so good. Polarized light can help solve the problem. Viewed with the new specialist camera, the mudflats, which reflect polarized light, are bright, while the unpolarized crabs appear darker against their background. This striking contrast also makes the large claw more obvious. The big claw is also used by the male to defend his burrow. Not everyone heeds the warning. Battle over. But there are more dangerous enemies to face: aerial predators. The quicker they can spot them, the better. And once again, polarized light helps them to do so. With the coast clear, a male re-emerges from his burrow. At last, a female. With the tide on the turn, he must work fast to win her over. And close up, his colours come into play. The brightness of his blue back could be the deciding factor. She may not look willing, but the pushing and shoving are all part of the mating ritual. One last shove, and she is in. Just in time. On land, colour is used in a multitude of different ways. The same is true in the sea, but there colour works in a very different way. This is Australia's Great Barrier Reef, and its shallow waters are full of vivid colour. The inhabitants of the reef exploit it to the full, with unparalleled and dazzling effect. The orange-red stripes of the harlequin tuskfish make it very conspicuous. But as light filters down through the water, more and more of its wavelengths are absorbed. And red is the first to disappear. So, as the harlequin swims downwards, his brilliantly coloured red body looks duller and duller. Different colours are absorbed at different rates in the sea, but some can still be seen at greater depths. Yellow and blue travel farthest, so it's these that many fish down here use to signal their identity. Most fish near the surface have good colour vision, but some of the smaller species can also see ultraviolet colours. To us, these yellow damselfish all look very similar. But using our ultraviolet camera, we can see that many fish have different patterns that are normally invisible to our eyes. And suddenly, it becomes clear that these two individuals are, in fact, different species. This lemon damselfish has distinctive spots on its gill covers. And this, an ambon damsel, has bright reflecting ultraviolet patches all across the body. It's a code, invisible to us, that allows these fish to recognize each other without attracting the attention of large predators, which can't see in the ultraviolet range. And it's on the seabed that you can find one of the most colourful sea creatures of all. The peacock mantis shrimp. This strange-looking creature's ancestry can be traced back 400 million years. And it has one of the most versatile kinds of eyes in the whole of the animal kingdom. It can rotate its two huge eyes independently of each other and in almost any direction. We have 3 kinds of colour receptors, but the mantis shrimp has 12, each with a direct link to the brain, so it can perceive colour faster than any other animal. And it can also detect the difference between polarized and unpolarized light. But unlike fiddler crabs, part of its body, like these paddle-shaped scales, reflect polarized light and may be used to signal to potential mates. The tail is also highly polarized and used to plug its burrow and send a message to warn off potential rivals. And by combining all its visual abilities, the mantis shrimp has become one of the most skillful of all predators. It also packs a powerful punch from club-like mouthparts, which it uses with great accuracy. These clubs deliver the fastest punch in the animal kingdom, and it's guided by its extraordinary vision. Whether underwater or on land, colour can be extremely useful. And the colours an animal develops can sometimes be influenced by where it lives and what it eats. The Atacama Desert in South America. There are 6 different species of flamingos in the world, and they all prefer to breed in those most hostile of environments, salt flats and soda lakes. We think of flamingos as being characteristically pink, but their feathers, when they first appear, are in fact white. Their colour comes from their food. The salty waters in which they feed are rich in algae and shrimps, both of which contain red pigments called carotenoids. These, over time, accumulate in their feathers and give them their bright colour. These youngsters were born last year. They still have their first greyish-white plumage. It takes time before the pigments become visible. Five years will pass before they become as pink as their parents. But it's not only the juveniles which are white. This adult female raised a chick last year, and the effort of doing so has drained her of colour. She put all her surplus food and energy into producing an egg and then feeding her chick. So she will need time to build up the body reserves needed to regrow pink feathers and breed. For those that are old enough and physically fit, it's time to find a mate. Only the pink birds take part in these courtship dances. Their colour is an indication that they're fit and strong. As they march through the water, each bird tries to stand out from the crowd. And the brightest will be the first to secure a partner. The white female can play no part in this year's display. She will need to eat as much as she can if she is to restore her colour. Maybe next year she will be able to rejoin the dance. Flamingos depend on their pink colour to attract a partner and breed. But there is one tiny animal in the Central American rainforests that uses colour not only to attract, but to repel.
This little frog uses colour as a warning. Its skin is full of glands which produce a deadly poison. So its colour is a very clear message. Eat me and you'll regret it.
You need a vivid message like this if you are a small, soft-skinned, bite-sized mouthful living in a dark, dense forest. The rainforest can be a scary place. There are hungry animals everywhere. For many, it's best to keep a low profile. But this little frog doesn't. It's a strawberry poison dart frog, and it's not much bigger than your fingernail. And yet he is one of the deadliest creatures here. His bright skin secretes a toxin. In the mouth of a predator, it can cause respiratory failure, convulsions, and death. Predators recognize his color as a sign of danger and avoid him. Such frogs also live on a group of islands just off Panama called Bocas del Toro. Living in isolation, frogs on each island evolved their own distinctive colors. There is a different one on each island. And yet, they're all the same species. They're different because the diet on some islands makes some more poisonous than others. And the more poison a frog has, the more brightly colored it is. On Solate Island, a red male is busy calling. This is his patch, and he's looking for a female. He should be popular. Females prefer bright, shiny skin, which is a sign of fitness. His color is also an indication to other males of his strength. He spots an intruder. He's about the same size, but he's a paler color. And he doesn't challenge the brighter frog. But this one is a different matter. He is a contender. Nothing for it but to fight it out. That did it. He won't be back for a while. And the reward? a new mate. For these tiny frogs, colour is central to all aspects of their lives. For protection, to dominate rivals, and to find a partner. For them, life is colour. In the next episode, the story of life in colour continues where the stakes are even higher, and colour is the key to survival. We discover how animals use colour to hide from predators and from their prey.